Great. Thank you, everyone, for coming to LLM 101. It's my pleasure to introduce Dr. David J. Gunkel, expert in the philosophy of technology, specializing in the moral and legal challenges of artificial intelligence and robotics. If you've ever wondered whether robots deserve rights or how AI is reshaping our ethical and legal frameworks, you're in the right place, because Dr. Gunkel has literally written the book on it, actually multiple books. His work includes The Machine Question, Critical Perspectives on AI, Robots, and Ethics, Robot Rights, and Person, Thing, Robot, a Moral and Legal Ontology for the 21st Century and Beyond, as well as the recently released Handbook on the Ethics of AI. With over 110 scholarly articles to his name, his research continues to shape the way we think about AI's place in our world. Dr. Gunkel is a distinguished teaching professor and presidential research, scholarship, and artistry professor, and he currently serves as the chair of the Department of Communication. And we're thrilled to have him here again today to help us navigate the fascinating world of large language models. Please join me in welcoming Dr. David J. Gunkel.
So thank you, and thank you all for showing up this afternoon and for your interest in LLM 101. As the title, I think, lets you know, this is going to be entry-level material, and it is designed for people with little or no background. If you have no knowledge whatsoever of how these things work or what they all mean, this is the place to be. If you even have a little bit of a knowledge, hopefully we can help get that organized. And my goal in all of this is to provide all of us a better understanding of these technologies, because we are using them already and our students are using them, and we're having to recalibrate a lot of what we do in higher education to respond to what these things are and the opportunities and the challenges they present to us. But more importantly, beyond understanding how they work, I want to help us build some confidence in responding to these opportunities and challenges that they place before us, so that we are able to make informed decisions moving forward, not only in our own classrooms, but in our departments and in the university as a whole. So let's get it started here. And what I want to do is start with an epigraph that I've taken from a science fiction writer, Arthur C. Clarke. And Clarke writes this in 1962. Any sufficiently advanced technology is indistinguishable from magic. So when technology is confused with magic, we are not in control. It is. And as a result, we often feel powerless to do anything about it. So my task today, framed by this epigraph, is quite simply this. I want to demystify the technology of large language models. And in doing so, I want to put us in control, not only of our technology, but also of our own destiny with this technology, because it now affects all of us, irrespective of discipline, irrespective of expertise, irrespective of career. And as a result, it is now all of our business to at least understand enough of this technology to make sense of how it impacts our world and our lives. So let's get things started with a basic definition. And this is a rather good and concise characterization. I'm going to read it here. A large language model is a type of artificial intelligence program that processes and generates human-like text based on patterns and examples it has learned from a vast amount of data. These models are designed to understand and respond to queries, complete sentences, or even generate content in a conversational, informative, or creative manner. And it's a fairly good definition, and it might not surprise you that I got this definition from a large language model, specifically by prompting OpenAI's ChatGPT to tell me what is a large language model. Now, obviously, OpenAI's GPT series is not the only large language model currently available. There are competing products from Google, from Anthopic, and now with DeepSeek. So when we talk about large language models generically, we're talking about a range of different kinds of technologies. But I think for most of us, we're still reeling from the impact of ChatGPT in 30 November of 2022. And that's the algorithm that has most of our attention as we describe and discuss these things. Now, as with any technological innovation, responses to the large language model have gone from one end of the spectrum to the other. On one side, you have rather excited proclamations that large language models are beginning to show signs of artificial intelligence, or as a paper from a team of Microsoft researchers once described it, sparks of AGI, or artificial general intelligence. On the other side, there are rather dire predictions about the fate of writing and the end of the human writer. And we've seen a number of articles recently with kind of apocalyptic titles: the end of writing, the end of the human writer, the end of writing, etc. So here's my plan of what I want to do in today's presentation. It'll take me about 35 minutes to get through this, and then we'll have plenty of opportunity to round out our hour together with Q&A. So first, I want to begin by demystifying the large language model and, and opening up the black box, providing a rather high-level explanation of the inner workings of these devices. After that, I want to do a cost-benefit analysis, evaluating the opportunities and the challenges of machine-generated written content. And then lastly, I want to return to some of these bigger questions about machine intelligence and the future of writing to get a handle on really what the impact of these things are and how to sort out this kind of very polarizing debate that we're facing right now. So let's start with demystifying the large language model. A language model, we can say, is a simple probabilistic representation of a natural language like English, German, or Vietnamese, and it can be used to perform tasks like next word prediction. You already have some familiarity with this because there's already a language model built into your mobile device with the next word prediction algorithm that helps you type text when you're sending a text message or composing an email. So let's get a handle on how this works with next word prediction by considering the following statement from that rather famous soliloquy that appears in Shakespeare's Hamlet. And there are a number of different words that could fill in the blank that you see in this statement. But of all the words that are available in the English language, there is one word that has a higher probability of occurring than the other words. So a language model like the autocomplete function that's built into your mobile device tries to predict the next most probable element in a sequence, whether that sequence concerns letters that make up a word or words that make up a phrase. So very briefly here, your phone doesn't know what you're trying to type. All it knows is that when you type to be or not to be, it has an idea that the next probable word in that sequence, the word that has the highest probability of occurring next, is question. So the autocomplete algorithm isn't understanding what it is we want to say. It simply takes the input, cycles through a set of available words, and identifies the one that has the highest probability of occurring next. Now, in order to achieve this, we could, theoretically at least, assign a probability score to all possible sequences of words that could occur in a given language, like English. But it turns out if we try to do this, for every possible sequence, we get a number that is astronomically large, something in the range of 10 to the 50, which, as you know from your mathematics, is a really large number. Now, we can reduce this number not only by eliminating those sequences that are grammatically incorrect or simply nonsense, but also by modeling word dependencies instead of entire sequences of all possible words. So let's look at how this word dependency stuff works. Consider the following word sequence derived from the book of Genesis in both the Christian and the Jewish scriptures. In this sequence, each word depends on the one that comes directly before it. The word was, for instance, depends on earth, and the word formless depends on the word was. This is what is called a time series. But there are also repetitions of the word was in the passage. In fact, was occurs 3 different times, and therefore actually has 3 different sets of dependencies. So we can actually economize things by merging the 3 instances of was and applying probabilities to its different dependencies, or what are also called edges. When we do this, we not only reduce the number of probability sequences that need to be ranked, but we can use this model to generate other sequences of words that have a high probability of being valid sentences, even though they did not previously occur in the example that we're working with. Thus, in this way, the model, once it's completed and working, can be used not just to predict next words in a commonly used and existing phrase, but we can also use it to originate a number of different sequences of words that didn't previously occur. Now, modeling dependencies is better than trying to model all possible word sequences. But even then, the number is still too large for us to handle. So we can resolve this problem by using an artificial neural network, or an ANN, to approximate the dependencies for us. In order to do this, we first need to turn words into numbers that can be processed by computers. And this is because computers don't understand words like you and I understand words. Computers process and compute numeric data. So we got to transform words into numbers. And this is done with what are called word embeddings that assign an ordered array of numbers, or what is also called a vector, to each of the words in our sequence. In one common model, the English Wikipedia model, for example, the English word dogs can be represented by a vector that consists of 300 individual numbers. And each word vector, each ordered array of numbers, represents a point that can be plotted in an imaginary word space that has hundreds of different dimensions. Thus, words for us that have similar meanings or semantic associations, like dog, puppy, and even cat, insofar as cats are also a domestic pet, can cluster together in this imaginary word space, while other words that have little or nothing to do with each other are situated farther apart. So at this point, we could set up and train an artificial neural network to perform next word prediction by feeding it lots of word sequences and then progressively adjusting the weights on the connections between the individual neurons in its neural network. But it turns out that getting a single artificial neural network to do this, even a really complex artificial neural network with lots of hidden layers, is something that is still too difficult a task. So we need to reduce the complexity of things. And to do this, we can capitalize on another feature of human language. And again, let's proceed by using an example. In this case, a well-known rhyme that is missing the last word in the sequence. Even if you have never encountered this rhyme before, there's a good chance that you could make a reasonable prediction about the missing word. In fact, you could probably do it with only a few pieces of information. So in predicting and completing word sequences, we don't need to pay attention to every single word and its dependencies. We can limit our attention to just a few crucial words in our sentence. And we can do the same then for our algorithm by adding an attention network to the next word prediction artificial neural network that we just talked about. This combination is what is called a transformer. And the T of transformer is what you see in the acronym GPT, as in general pre-trained transformer. Now, here's how this all works. The attention network takes the input words, again, not the actual words, but the word vectors that represent them, those big sets of numbers, and assigns each one an attention value, or a weight, in the form of a fractional number between, say, 0 and 1. These weights are determined by the relationship each word has to other words, producing something called a context vector. And the attention network formulates a context vector for each word in the statement. It then multiplies these weights by the numeric value of the word vectors. This way, the attention words are given attention. That is, their numeric value is increased, while the attention on the other words is, by comparison, decreased. So, in this case, we want to have attention given to the word star to avoid the network from putting out the result shine. And the way we do that is by adjusting the weights in the attention network to increase the intensity on the word star and decrease the intensity on the other words that may have contributed to the output of shine. As you can imagine, this process is iterative. We go back and forth again and again, having the network spit out stuff, identifying wrong things, making alterations, and then doing it again and again and again. So it's a lot of trial and error that really characterizes how these things work. This process of making the network spit out various results and then seeing whether they are correct or erroneous is called backpropagation, because the resulting error, when the error occurs, is fed back into the transformer and used to make the adjustments to the weighted values in our attention network. But now we're getting a little bit ahead of ourselves, because this involves already training. Like any artificial neural network, the transformer needs to be trained. And doing so requires text, in fact, lots of text, meaning not only all of the internet, but also every publicly available book and document that exists in digital form. In effect, tech companies like OpenAI and Google and Anthropic have trained their large language models by scraping textual data from every conceivable corner of the digital universe. This initial training or pre-training, and that's the P part of GPT, is iterative. And with each iteration, the objective is to have the model predict the next word in a particular sequence of words that have been extracted from its sampled training data. Now, obviously, one transformer has some capabilities, but it's not adequate for predicting the next word beyond a simple rhyme. So in order to tackle more complicated tasks, like generating an email message from a prompt or responding to user input, we need to expand its capabilities. And we can therefore do this by stacking up layers of transformers, such that the output of one becomes the input to the other. And in this arrangement, the lower levels of the stack handle basic word relationships and syntax, and the higher layers can be directed at more complex relationships like semantics. It is this density that allows the stack of transformers to generate all kinds of different word sequences from a user prompt. And that's the G part, generative, of the acronym GPT. Now, GPT-3 has 96 layers, and its successor, GPT-4, boasts 1.8 trillion parameters across 120 different layers. This is what makes these language models large. So the largeness of them relates to the density of the transformers that comprise the final model. Now, once it's trained, a large language model can provide legible text content in response to user prompts. If, for instance, I prompt OpenAI's ChatGPT with the statement, write a concise description of how large language models process and respond to user prompts, I obtain the following output. So, as you can see, this is a rather accurate response, but again, let's look into it a bit further. When I submit the prompt sentence, the algorithm first parses or breaks it up into discrete elements that are called tokens. Once tokenized, the model begins to generate a response that sounds right. In performing this action, the large language model, at least the ones we've known so far, doesn't go through any search on the internet or look up anything related to the words contained in some kind of memory. More recent innovations like DeepSeek and some other innovations with the OpenAI products are moving in that direction. But for the basic version of ChatGPT that was available to us already in November of 2022, it did not have this capability. So we're not talking about a search engine. And what is happening here is that the large language model is just generating sequences of words one after another in a sequence that sounds right, meaning that the linear arrangement of the words adheres to the statistical probabilities that were initially discovered in the training data. All right, that's a very quick overview of how these things work at a very high level. There's a lot more detail, obviously, that we could get into, but that's not necessary for getting a handle on what these things mean for us. I just want to demystify enough of it so we know they don't understand language, they don't understand us. All they do is string words together. And they string words together in a way that sounds right, but isn't necessarily right. And I think that's going to be the important thing as we move forward here. All right, though many of the technological innovations behind the large language model have been around for years, publicly available applications of these technologies are a rather recent development. And everything seems to begin, as I said, on the 30th of November, 2022, which is the day that OpenAI launched ChatGPT and changed our lives in ways that we are still trying to figure out. After that date, ChatGPT and the competing large language models from Google, Anthopic, and others have been everywhere, and advocates and critics have been lining up either to sing their praises or issue dire warnings about the social impact and costs of these technologies. Now, LLMs are powerful applications capable of generating human-like textual content from a simple prompt. As such, they can perform a wide range of different tasks, including but not limited to the following. They can do basic text generation. They can engage in seemingly conversational interactions with users. They can do language translation. They can do information summarization by providing them with a text and asking them to summarize it. They can answer questions, do what is called sentiment analysis, trying to decide whether a piece of writing is positive or negative. They can correct grammar and style, and they can provide educational assistance. Now, this list of capabilities is rather impressive, and maybe even more impressive is, again, the fact that it was generated by ChatGPT from a prompt briefly describe what large language models can do. Now, despite these remarkable capabilities across the wide range of communication tasks, these technologies also have a number of limitations and important challenges. And I want to look at three in particular: bias and hallucination, intellectual property and copyright, and then lastly, the one that is only recently getting attention, environmental impact and sustainability. So let's start with bias and hallucination. Large language models generate sequences of words that sound right, but sounding right doesn't mean that they are in fact right. Some sequences of large language generated words, like large language models process and respond to user prompts through a series of steps, not only sounds good, the words are in a sequence that is grammatically correct, but they also express something that is factually accurate. Other sequences, like this one, are a little different. Here we have a sequence that is also grammatically correct and sounds right. But whether a large language model actually understands intent is debatable, if not entirely inaccurate. Second, we have problems with bias. Large language models can inherit and even amplify biases that are present in their training data. Because the word associations produced by the large language model are derived from the way that human beings have used words, especially the way they've used them on the internet, these models can unwittingly reproduce existing prejudices. If, for example, the word doctor has been found to be most commonly associated with the pronoun he, and nurse most commonly associated with the pronoun she, the large language model will tend to produce content where doctors are gendered male and nurses are gendered female. And since the source of the bias is in the training data, and the training data is vast, both developers and users are typically not aware of the problem until the algorithm starts generating text and spitting out statements that are at least or could be interpreted as sexist, racist, ableist, ageist, etc. Hallucination is another problem related to this. In the context of large language model AI, hallucination refers to situations where a large language model produces output that looks legitimate. That is, the text is coherent, well composed, and grammatically correct, but it turns out to be factually wrong, fabricated, or nonsensical. Large language models have generated academic papers that make reference to sources that don't exist. They've written recipes that include ingredients that are not fit for human consumption. You may remember not too long ago, Google's large language model told users that if they want to keep their cheese stuck to their pizza, they should use glue. Obviously not something you'd want to do if you're going to actually eat that pizza. And they have produced financial reports where most, if not all of the data has been entirely fabricated. Now, this problem is not a matter of the large language model making a mistake or intentionally lying. They are as incapable of fabricating falsehoods as they are of telling the truth. Despite this fact, large language model hallucinations can be a problem for the individuals and organizations that rely on these algorithms to produce content. So like bias, this problem only becomes evident in the output, and then only by scrutinizing the results and performing thorough fact checks. All right, The second thing I want to look at is the training of large language models and the question of intellectual property and copyright. So the training of large language models, as I said, requires massive amounts of textual data. Basically, every piece of writing that resides on the internet and all books and documents that are accessible in digital form. But not all text is created equal. Some text, like government documents and literary classics from the past, are public domain, meaning that this textual data can be copied and reused without infringing on anyone's intellectual property rights. Other texts are protected by copyright and therefore can only be reused by others if one obtains permission or negotiates a licensing agreement. And it turns out that many of the currently available large language models, like OpenAI's ChatGPT, have been trained on digital text without necessarily paying close attention to or differentiating the one category of text from the other. And as you may have seen, this has recently blown up with authors, journalists, screenwriters, and publishers complaining that OpenAI has been using their content without consent, compensation, or credit. This is the point of contention in a lawsuit recently brought by the New York Times against OpenAI and Microsoft. In their filing in U.S. District Court of Southern New York, the Times alleges that OpenAI and Microsoft used the news organization's copyrighted content to train their large language models, and as such, not only violated copyright, but now facilitate the production of content that unfairly competes with the news organization. OpenAI and Microsoft, for their parts, have defended their actions and sought protection under the fair use exception that is contained in US copyright law. They have further argued that compensating publishers like the New York Times for use of its textual content would render the training of large language models prohibitively expensive and hinder technological progress. And this is not the only case that's out there right now. There's about 34, I think, of cases like this that are currently working their way through the US legal system. The last challenge I want to look at is environmental impact and sustainability. Processing these massive amounts of data takes time and resources. It is estimated that training a large language model the size of ChatGPT on a single GPU would take 355 years. But the transformers that power the large language model are designed to be operated in parallel, which means the same task can be accomplished in about a month with several thousand GPUs. Doing so, however, requires loads of expensive digital equipment and massive data centers, which is why these models, so far at least, are only able to be developed and supported by multinational corporations like OpenAI, Google, and Anthopic. Because they are resource intensive, large language models have a very real environmental impact. According to Syed Mohseni, a researcher at Washington University, ChatGPT responds to hundreds of millions of queries a day. At this rate, he estimates that the servers that support the algorithm consume approximately 1 gigawatt hour per day, which is equivalent to the daily energy consumed for about 33,000 US households. Rapid growth in this sector has led to other researchers to predict by 2027, AI servers could use between 35 to 134 terawatt hours annually, which is similar to what Argentina, the Netherlands, and Sweden each use in a year. Now, these are, and I want to point this out here because it's important, these are all estimates that are made by researchers. The exact figures are actually difficult for us to obtain because there are, at least in the US, no federally stipulated rules or guidelines for reporting this information. Water is a problem, but let's talk about electricity first. So I think it's telling about the electrical problem that Sam Altman, who is the CEO of OpenAI, has said that the continued development of large language models will not be possible without a new breakthrough in energy generation. And I think it's also telling that recently both Microsoft and Google have begun exploring buying nuclear power plants to help fuel the electricity needs of their models. Now, electricity is a problem, but also is also an issue. ChatGPT may have been developed in San Francisco, but it resides in Des Moines, Iowa, where the server clusters that support the large language model quench their thirst on the Midwest's rather ample supply of clean, fresh water. In response to a lawsuit filed by local residents in Des Moines, it was revealed that the training of this powerful generative AI system, just the training, not the operations of it, consumed 6% of the district's water. Now, this number may not seem like a lot, but it tells us two things. First, AI is thirsty, and its need for water is only going to increase. How much and what this means is the second item. As again, there are no federal regulatory standards for reporting and evaluating the environmental impact of these technologies. All right, so let's circle back and conclude by looking at some of those philosophical questions that we started with, and really returning to those two big questions that I gave at the beginning. And that is, are LLMs showing signs of intelligence on the one hand, and are large language models the end of human writing? This is where a lot of the popular press is recently. So let's begin with intelligence. Large language models can process and generate language. They can write seemingly original content, and they can converse with us. Having the ability to use language has been one of the defining conditions of human intelligence from the beginning. And it is for this reason that the ancient Greeks had defined the human being as the animal possessing language, or the zoon logon echan. So this goes way back to ancient times. But it is also the benchmark of machine intelligence, beginning with Alan Turing's agenda-setting paper from 1950, in which language use was taken to be a sign or a symptom of intelligence. Thus, it's not surprising that researchers and developers have perceived in the capabilities of large language models the signs of intelligence. In fact, OpenAI is already positioning itself as being in the AGI business. About a year ago, OpenAI stopped being a large language model company, and they rebranded themselves as being in the AGI business. And so now all of their marketing promotes their company as developing AGI, which is a shift in how they even talked about themselves just a year ago. But it is, I think, the Lemoine affair that really illustrates what's at stake here. In June of 2022, a Google engineer named Blake Lemoine claimed that LaMDA, a large language model being developed by Google, was conscious and therefore was a person deserving of moral respect and consideration. Google countered, not only arguing that LaMDA, like any computer application, was just a thing, but suspending and then eventually firing Lemoine. So what you have here is a he said versus they said kind of dispute. And the reason there is even a dispute at all is because of something philosophers often call the problem of other minds. Here's how Paul Churchland once described it. How does one determine whether something other than oneself, an alien creature, a sophisticated robot, a socially active computer, or even another human, is really a thinking, feeling, conscious being, rather than, for example, an unconscious automaton, whose behavior arises from something other than genuine mental states? And the problem is that you can't tell. All you have to go on are external behaviors, like language use, that we take as signs that are caused by intelligence. But this debate is not just a matter for philosophical speculation. It has important ethical consequences and legal outcomes that matter for us. If LaMDA lacks consciousness, as Google asserted, then it is just a thing that we can use and dispose of as we see fit. If, however, LaMDA is conscious, or even just showing signs of initial kinds of consciousness, as Lemoine had argued, then it might be closer to being what we would recognize as another person with rights and responsibilities that we would need to recognize. And you can see that's pretty much what was at play in the Lemoine conversation with Google. Now, ultimately, the question, does writing have a future, I think, is actually more important even than the question about intelligence, because this question depends really on how we understand, define, and operationalize this term writing. If we understand and take it literally, that is, as the process of arranging words or linguistic tokens in linear sequence on some tangible medium, then writing will indeed continue well into the future. But who or what does that writing and how it affects the meaning of any particular written content is a question that has actually always been in flux and rather dynamic. Large language models actually do little more than render all of this legible. If we limit ourselves to the usual way of thinking, a way of thinking that Derrida had called logocentrism, it's hard to see this transformation, or what some have called a crisis, as anything but the signs of end times. From this vantage point, the future of writing appears to be in danger, as the customary understanding of the written word as a means of human expression and the preferred method for evaluating how and what others think seems to have hit an operational limit. Consequently, it's not just literature, but literacy that seems to be threatened by the emerging technology of the large language model. But from another perspective, this is an opportunity for us to challenge and disrupt the usual ways of thinking. What we have now with large language models are things that write without speaking, a proliferation of texts that do not have nor are beholden to the authoritative voice of an author, and statements the truth of which cannot be anchored in and assured by a prior intention to say something. Understood in this way, then, large language models and other forms of generative AI provide us with the unique opportunity to do some rather deep reflection on the nature of language, who or what can be said to possess it, and what this ultimately means for us, the entity that had defined itself as the animal with language. So even if large language models do not think for themselves, they are certainly things for us to think with. And of all the things we need to begin thinking about, especially in the work that we do in the university, is for us, what is the role of writing in higher education? What does writing do? And what is the threat to writing from the large language model? So in higher ed, writing serves really two different roles. It can be an end in itself, or it can be a means to an end. Let me just break these out a little bit here. In some cases, we have our students write because we want the written product. In this case, we are looking for things like conference papers, the master's thesis, or even the dissertation. It is also what we want when we engage our students in the production of creative work, like mobile apps, original music, screenplays, and short stories, as we now have generative architectures for creating not just text, but audio, video, and code. In other cases, probably the vast majority of cases, we have our students write as a means to evaluate what they think and how. Here, we are less interested in the product and more concerned with the process, as writing is routinely used as evidence of student learning and comprehension. So how we address and integrate large language models into our instruction is going to depend on this difference between the two different ways that we use writing in higher ed. When writing is the product, we need to engage our students in learning how to use these tools to support their efforts by developing best practices and modeling responsible use for them. But when we are more interested in the process, we not only need to contemplate putting limits on student access and use, but more importantly, I think revising evaluation methods and teaching the debate in a way that helps our students understand what is at stake in these new tools and how they affect the learning process. Okay, that is what I have by way of prepared things. There's time here in the next 20 minutes for Q&A, but if you're like me, the best questions are going to occur to you later, like a day or two from now. If that happens, my contact information is there. I'll also point out a lot of what I talked about today is recently published in this book, AI for Communication, which is a really thin volume from Routledge that can be read in the course of a weekend. It is designed for students, and therefore it is really meant to lower the bar for people outside data science, computer science, and the STEM fields, people in the humanities, the social sciences, and the arts, to get up to speed on these things so that we understand better what these technologies are and we don't treat them as a magical object. So that's what I have. Thank you.
Thank you so much, David. Do we have any questions for David? I know we had a couple of comments in the chat. while you were speaking, one about Byron looking to put an AI data center next to its nuclear power plant.
Yeah, that I had not heard about. I've heard about it happening elsewhere in the world. I think the fact that Google and Microsoft are thinking about buying a nuclear power plant. In fact, I think Microsoft already has. This is quite telling of the amount of electricity that these companies envision being necessary to build these models. But I also point out that one of the things that makes DeepSeek rather competitive right now, and one of the reasons why people are very excited about it, is that it requires a lot less resources than are necessary for the large language models that have been developed in the US. Yeah, you're right. Someone just said that Microsoft bought 3 Mile Island. Exactly right. So they're going to they're going to try to make 3 Mile Island an operational plant once again. Thank you. Yeah, I forgot it was 3 Mile Island.
We have a question, Laura.
Sorry, I had to get everything turned on. David, I really, really appreciate this presentation, but for me, you've raised more questions than you've answered. So thank you. You've done, yeah, good job. And now I need to get the book. But can I ask a couple questions? One is, did Google anticipate the need for this kind of text when they started digitizing all the books they could get their hands on? Is that possible, or am I reading back paranoia?
So they didn't do it for their large language model because that technology as such did not exist yet. They did it mainly for Google Translate because they wanted to build the neural engine, the neural network engine for their most advanced version of Translate. And the reason they wanted to do that is they wanted to find what are called parallel corpora, which are texts in more than one language. So they can align sentences from one language to another and then use that as the engine to drive initially their statistical translation system, and then later their neural network machine learning based system. That's originally why they did that. But obviously it feeds into this too.
Thank you.
Alicia, you're next.
Hi, thank you. So this was obviously very helpful. I agree with everyone who said that it was helpful. At the end, when you said that we should teach the debate, I was going to ask if you had any recommendations for what we could assign students to read. I'm betting your book would be a good recommendation, but is that true? And or do you have any other suggestions?
So one of the reasons I wrote the book is precisely for this.
Okay.
Because I wanted to teach the debate to my students. I wanted my students to appreciate why we are even having this conversation. Because if they don't appreciate why these are important questions, they will use this without recognizing what the costs are and what the consequences are. And
Exactly.
so the more we are able to inform them about what goes on behind the scenes with these things with regards to access to data and the questions of intellectual property and copyright, what the environmental impact is, and what the results with regards to hallucinations and biases are, it's hard for them to appreciate what happens when they prompt the model. And what we don't want is for them to be power users that use this thing all the time and don't know why it does what it does. And that's why I wrote this, but there's other things out there that people have written. There's even some nice online tutorials and videos that are widely accessible. And all you got to do is begin searching around for this stuff. I can send you some things. If you're interested, just send me an email and I'll send you some of the resources that I've put into my syllabus.
Oh, fantastic. Thank you so much.
Sure.
And if you want to send those to me, David, I can send them out to everyone who's here today.
Not a problem.
Jackie, you were next.
Yeah, hi, great presentation. Thank you very much for taking the time to speak to all of us. I am actually an instructor in the STEM fields. I teach earth science, and my classes are both lab and non-lab courses, and I want to integrate some assignments that are that use AI, but I'm not sure how to effectively do that for classes that are mostly really hands-on courses. And I'm not sure if that's even doable with an AI thing. I'm just not sure how this is going to be helpful for my students, but at the same time, I want to prepare them for eventual work that they will have to use with AI as they get into the higher levels of academia. I teach freshman students. So if you got any advice where I can go from a STEM field perspective, that'd be great.
So what are you having your students do that seemingly is not working with large language models, if I may ask?
Yeah, so I do a lot of rock and mineral identification and interpretation. So that's a lot of looking at hand samples, testing them and all that. I am trying to integrate more disaster analysis. So that's kind of where my background is. So I want to integrate more disaster and hazards analysis where they can go and analyze a particular event and kind of get a well-rounded.
Nope, I think we
We
kind of
lost.
lost your audio, Jackie.
Can you hear me now?
Yeah.
Okay, I'm sorry about that. So just hazards analysis, threat mitigation, trying to analyze environments for possible disasters, and mapping, map interpretation, stuff like that.
So it sounds like you don't need large language models for that work, because that's a lot of basic image recognition capabilities and other kinds of things dealing with visual data as opposed to textual data. But my guess is at some point, students have to write this stuff up and make it accessible to other researchers or to you as the
Correct.
team leader or something. They're going to be using large language models to help them write these things. And so having them understand when using a large language model to assist their writing is going to be a crucial way of helping them sort of prepare for this future. I'll give you a really good example of something that happened recently with a Stanford researcher named Jeffrey Hancock. He was asked to be an expert witness in a court case, and he prompted ChatGPT to write the brief for him, and then he turned this over to the court. And it turned out that the large language model made references to court cases that didn't exist. Now, that created quite a bit of embarrassment for him as a researcher, but also for the institution to whom he with whom he's employed with. We don't want that happening to our students, obviously. And so knowing that they are already using these things and knowing they will be using these things really makes it such that we have to not only guide them on best practices, but we've got to lead by example in showing them how, as researchers and scientists and scholars, we are already using these things to show them the right way forward. Because if we just expect them to figure this out by themselves, we're not going to get to where we need to be.
Thank you very much. It's good to know that you said that, because I do have assignments that I ask them to go into, like the Google Baird, and be like, what is the answer that you get? Is this logical? Let's see if this resource is good. Let's see if we change the question just ever so slightly, how a different answer pops up and why. I was hoping that's what you were going to say, but I didn't want to just say, hey, is this great? So thank you very much for that. I appreciate it.
Yeah, thanks.
Jason, you're next.
Hi, David. Thanks a lot. I actually have several questions, but I wanted to touch on the sustainability thing. This was along about slide 37. You're talking about the use of all the water in the Midwest. And here locally, even in DeKalb, there's a lot of talk about they're freaking out because, and probably rightfully so, about using the Facebook data center. Apparently in the contract has the ability to dig new water wells whenever they want in, arguably the richest farmland in the world. So a reality check, this water is to cool the server so all this keeps working, right?
Correct.
And then is there some reason that it has to be fresh, clean water? Can nobody design a system that can use like recirculated water or ocean water or something like that? I'm just curious about that. Thank you.
I know this from my work with engineers that build power plants. You can't cool these industrial facilities using salt water. Why that is the case, I don't know for sure. You have to talk to individuals who do more of this. But you need basically cool, clean, fresh water. Basically what we need to drink is what needs to go into cooling these clusters.
All right, Ken, you're up next.
Hi, I just wanted to touch base. I know there was a questions, not a question necessarily on what an LLM is, but using it. I've used Copilot, ChatGPT a little bit, and then I'm also have used what's called Magic School. It's an AI program because I teach the teacher prep. So I've tried going ahead and played with it, said, go ahead and make up some examples that I could use for my class so my students can see this kind of examples that they could give to their students when they start teaching. Part of the issues that I've brought up with them on the AI, and it comes to what you were saying about what they're taught on, I guess, the LLM. There's not a lot of diversity in the names, nor in the numbers themselves. So sometimes I gave like 30 different problems and there wasn't diversity in the names that we would use. And as teacher prep, we're saying, hey, we want to make sure we include all these different types, the different names in there. Don't always use Bob, Sue, Jill, and those. So that's some of the things I just wanted to address. But again, Magic School seems to be pretty good. It does have some possibilities up to university and professional prep. I haven't gone into it for that level. Like I said, I've just used the elementary level of creating it. So it's not something for us using it to be scared, to be quote scared, play with it a little bit. And it, by the way, that I got it, it's free. I don't pay for anything like that. Same thing with Copilot, which is the Microsoft, I think. No. Yeah.
Yeah, it is.
Okay. That's what I just wanted to say. So it's not this big thing out there. It's something that you can get your hands on and play with a little.
Yeah, no, we've been able to play with these things since their release. But I will point out that all of these wonderful platforms that we know and love, like OpenAI and Microsoft and everybody else who's creating these new toys for us, they often work with a drug dealer business model. And the drug dealer business model is first taste is free, but if you want to keep using it, you got to pay. And I'm afraid that a lot of these are moving in that direction. And you can imagine, especially if any of these lawsuits find in favor of the plaintiffs, like the New York Times or any of the other publishers that are filing these lawsuits, it's going to make training these models expensive. And when these models become expensive to train, that money is going to have to come from somewhere. So I'm very glad they're free and it makes it available to me and my students, and that's great. I'm keeping an eye on how the business model is going to be evolving, because I've learned from the internet platforms that these things usually evolve in the direction of freemium services. That means free for a time, later on subscribe.
We have a question in the chat. What advice would you give to literacy teachers in K-12 as they teach children using generative AI?
Yeah, this is a tough one. I don't know I don't have a silver bullet answer for this one, because inevitably kids in grade school are going to get their hands on these things, and we're not going to be able to stop them from getting their hands on these things. And just like with the cell phone, there's going to be peer pressure among their group of friends to use it, and therefore, if we as parents decide to, somehow control use, we're going to be getting into the way of the pressure from the peers. I think what inevitably has to happen is we need to begin developing curriculum addressing these tools early on in their educational career. If we wait till they get to us in freshman year or sophomore year, it's going to be too late, obviously. It's going to have to be in primary and secondary education where a lot of the first exposure to this takes place. But that's a big ask, because we then are asking basically classroom instructors in primary and secondary education to be conversant with and confident with this technology in a way that they are able to engage their students using it, and doing so safely in a way that is responsive to the parents of students, but also the school districts, et cetera. So there's a lot going on with regards to addressing that question. It's not something I research and have done much work on, but it is, as you already know, a really crucial question for all of us, because eventually those kids are going to be our students.
John, you were next.
Yeah, so I had two questions. The first one is, so the array method for text determination in AI models, is that a very similar method for generative code?
Yes, it is.
Okay. And then second is, you talked about licensing restrictions or potential licensing issues with paywalls and training AI models. But what about the opposite? Because I have to imagine that software developers are using AI generative code and potentially patent products. So who owns the licensing right if they file patents with AI generative code in it? Does that go back to the AI company, or does that fall onto the developers?
It's a really good question, and it's one that we don't have an answer for yet. It's part of a few of the lawsuits that have been filed recently. And it is something we're going to see. I think in a way, it's going to be a repeat of the experience we had with remix and hip hop. Remember 3 decades ago when you started sampling music and making new music from old music, the question was, well, if it's new music, who owns the copyright to that? Is it the stuff you sampled, or is it you? And if you're sampling stuff, do you have to pay for the samples, or can you use it under fair use? We're having a very similar conversation about generative AI and the use of training data from either text, images, or audio. And as you can imagine, the way in which these court cases go are going to make a very large determination in how a lot of these questions get resolved.
Okay, perfect. Thank you.
We have another question in the chat. Knowing the power and water usage, how can we teach our students how to properly use Gen AI, which they will obviously need to know how to do without feeling obscene?
Yes. So it's funny. When I was hired by NIU back in the 20th century, I was hired because we were at that time facing a technological disruption that was upending higher education in ways that we never thought possible. And that technological disruption was the internet. And I had colleagues saying, well, do you think I should give my students access to the internet? Do you think I could use the internet in my class? Do you think we should be using, search engines to get research data? It took us, a good couple decades to work through what the internet did to us and what it meant. I think we're at that moment right now with large language models and generative AI. We are right at the beginning, and it has slapped us upside the head in the same way that the internet did back in 1994. And getting a handle on what this means is going to be a struggle that we all have to face individually, but also collectively, as we share ideas of what's working in the classroom, as we complain about what is going wrong in our designs for delivering curriculum, and as we are being asked by our departments and our colleges to come up with best practices as we move forward. There is, I think, reason to be optimistic that we will figure this out, mainly because we figured out the internet. But a lot of what we did in the past is not necessarily going to apply cookie cutter to the future. I think we've got to take our experience with the internet and previous disruptions as a way of recognizing that we can meet the challenge, but the way we meet the challenge is maybe unique to this brand new technology that's very different from what the internet gave us previously. So in my classroom, I engage my students with using this stuff from day one. And I try to open opportunities for them to use it, but use it responsibly. I try to develop exercises and evaluation mechanisms that invite them into exploring what the opportunities are, but also in the process learning what the challenges can be. And we make all of this a point of constant conversation, debate, dialogue, because I don't have all the answers. None of us do. We are going to generate them together, and we're going to generate them by experiencing this, one step at a time. But I think we can't go into our classrooms and teach the way we did prior to the advent of the large language model. If you give your students an essay exam and you say, take this home and write this exam, you know what you're going to get. And if you try to have your students do in an online course a presentation, chances are the presentation was written by the algorithm and the slides were generated by the algorithm. So the usual business, the usual way of doing things is really for us to rethink. And that is not something that is easy to do because we've gained a lot of experience assigning papers and doing presentations. But now it's time to think about new and creative strategies that can respond to this challenge.
Right, we have one more hand raised. Laura?
Thank you so much for this presentation, David. I really appreciate the demystification and the ways that you're removing magic from the equation. So I have two questions. One is actually for the other people who are here in the training. So I teach a couple of different writing infused classes. Are any of you interested in having a working group to think about how we teach writing in the age of AI? So specifically, some of the skills that we have as part of the core curriculum at NIU. And then the question that I have for you, David, is one of the concerns that I know some academics have is that, our ideas are our currency in academia, the words that we use, the ways that we put our ideas together. To what extent do we need to be worried about using AI with our research? To what extent does that leave us vulnerable?
Let me start with the first one. In terms of revising the teaching of writing, yeah, I think some sort of collaboration there would be really crucial, because the way that we teach writing is going to have to change, obviously. And how that changes is something we have to decide to do together. Another thing that would be good is some sort of AI across the curriculum. We can't silo the AI education. It's got to be everywhere now, because every field and every discipline needs to engage it and engage their students in it. And those are two things that I think are really crucial for moving forward. With regards to our research and these powerful large language models, the bad news is this. A lot of your journals that you are publishing your research in have made exclusive arrangements with these companies that create and train large language models. Elsevier and Routledge have recently signed agreements with Microsoft, making available the entirety of all research articles that they publish available to Microsoft for training its AIs. Other publishers like Springer are in similar conversations right now. So in terms of how we even publish our research is got to be something that concerns us. And it may mean, if you're uncomfortable with this, looking at smaller venues that don't get the same set of eyeballs, but doesn't funnel your research content into the large language model, if that's a concern of yours.
All right. Any last, I don't want to say any last words, that sounds ominous, but any final thoughts, David, before we end today?
For me?
Yeah.
Oh, sorry. Just to say thank you again. I know online presentations are sometimes not the most exciting things, but hopefully I've given you things to think about and given you some exciting new ways of approaching your own work when you engage these language models. And then again, if things come up, after this presentation that you need to know about, or you have some questions, you have my contact data, so feel free to.
Thank you so much, David, for presenting to us today and answering everyone's questions, and for replicating in this online venue the workshop that you gave in the fall.